Oh, what up, my road dogs? Back in action. This is topic 5.4, solving inequalities using addition or subtraction. So we got these two kids, Selena and Martine, they're waiting at the bus stop. The number lines, these guys right here, show the number of minutes T Selena and Martine each expect to wait. So let's zoom in on here and we can see how dorky this dude looks. Yeah, look at that guy. I don't know. It's giving me the creeper vibe. Anyway, so Selena is looking at this. She says that the bus comes every 15 minutes. Martine is looking at his phone. He says that the bus is delayed. So we've got Selena's expected wait time here. We've got 15 minutes. We've got this arrow going this way. And then Martine's expected wait time is right here, basically more than 15 minutes. And he's got his arrow going this way. One thing you got to notice is these circles right here and right here. This is a closed circle. That's what I call it anyway. That's a closed circle. And this, my friends, is an open circle. Okay. This is very important when we're talking about inequalities. We'll get into why in the next example, but just realize that those are different. Okay. There's a difference about them. Okay. So who expects to wait longer? Justify your response with a mathematical explanation. Well, we've got Martine's going this way, or Martin, I don't know, actually, going this way. So basically increasing in wait time. And we have Selena's basically being less than that 15. So I'm going to say, based on this, is that Martine should expect to wait longer. Because B/C, that's how I read because. Martine should expect to wait longer because it's more time, right? His time is increasing, right? His time is increasing. Okay. And then the next one. If Selena and Martine both waited 10 minutes for the bus, whose expectation was closer to his or her actual wait time, right? So we take a look here. Selena's is 10 right here. This line includes that 10, but when we look at Martine's, 10 is not included on his line. His is everything bigger than 15. So that 10 minutes is actually closer to hers because her number line includes that 10 and his does not. Okay, so we'd say Selena's wait time is closer to 10 minutes because her number line includes it, and Martine's does not. Includes 10, and Martine's does not. Excuse me, sorry. Okay. On the airline that Raul is using, this is going to be addition, by the way. The weight limit for both suitcases combined is 50 pounds. How much can Raul's second bag weigh without going over that 50-pound limit? So if we look at the graphic right here, we see that the weight limit's 50 pounds and his bigger bag is 38 pounds. Okay. So we'll call that the first bag. Okay. And let's see, what did I use? Just use W. W is the weight of the second bag, right? So you need to define your variables when you are doing these types of equations or inequalities, right? So we have something to work with. So I got that weight of the first bag is 38 pounds. I pop that right there. Okay. I add the weight of the second bag to it, which we don't know what it is. We're just hoping that it doesn't go over that 50. Okay. Now, normally you have seen equal signs here, but these are inequalities, right? You might have talked about this in elementary school when you were talking about what number is bigger than another number, right? You would be like, I don't know, 10 is greater than 7, right? Remember the alligator? No. Alligator wants to eat the bigger number, so he's going to eat that 10. 10 is greater than 7. This is kind of the same thing, but we've started adding in variables into them and a little bit of algebra, okay? So we solve these the exact same way that we do equations. This is a positive 38. We do the inverse or opposite of 38, which is negative, subtraction, okay? So we get W is less than or equal to, in this case, that's 12. Now on our number line, what did I see? I started at 8, okay. On our number line right here, I'm just going to throw some numbers. Didn't really have time to put the numbers on here because I was kind of rushing to do this document. So let me do a different color just to mix it up. That 12 is right here. We're going to put a circle, right? But now it goes back to talking about whether we use a closed circle or an open circle, right? Now, this says less than, and then the little bar underneath says equal to. So let's draw a little arrow over here and kind of do this. We would say less than or equal to. So that or equal to is a signal that we're going to use a closed circle. So close that circle, color it in, and since it's less than or equal to 12, the arrow is going to go the way that the inequality is pointing. So it's basically saying that that second bag can't be more than 12 pounds, but it can be 12 pounds or 11 pounds or 10 pounds, right? It just has to be 12 or less, okay? And that's how we work with these inequalities, okay? So Kyoko has completed 26 hours of community service. You know, no judgment here. I don't know if this is for a crime that she committed or if it's to like look good on her college application. No shade at Kyoko, right? Kyoko has completed 26 hours of community service. Her goal is to complete at least 90 hours this semester. Write and solve an inequality to show how many more hours H, that's our variable right there, it's got it defined there, Kyoko can complete to meet her goal. So H equals number of hours. Okay. And then we're going to say, we know that she's completed 26, and we're looking to figure out what that H is. Okay. So we're going to take that H, we're going to add 26, and this at least means that she needs to do at least 90, but it's okay if she does more. So we use that greater than or equal to, okay? Because it could include 90, which that's the or equal to, okay? Right there. And then we're going to take that 26, subtract it. Again, super similar to what we just did, right? Okay. And we get H is greater than or equal to 64. Okay. And then I'm going to pop just some numbers on here 60, 61, 62, 63, 64, 65, 66, etc. Right? You could fill that out. I don't feel like I need to. But we're at shoot. I guess let's just keep going, I guess. All the way up to 70. So we've got our 64 right here. And then this is kind of pointing that way. So that's the way our arrow goes. And I guess I already filled it in, right? It's a closed circle because it is or equal to. Okay. If it was just the greater than sign, this would be an open circle, and we'll see an example for that later. Okay. All right. The weather forecast predicted that the evening temperature could get as low as negative 12.5 degrees. Between afternoon and evening, the temperature dropped by 7.5 degrees Fahrenheit, and the forecast was still correct. What could the afternoon temperature T have been? Let's use pink. Okay. So we got that temperature. Okay. Dropped by 7.5%. That's kind of a clue, right? We're using subtraction in this. Sorry, guys. Should have led with that. My bad. So we've got that temperature. It dropped by 7.5. Okay. And the idea is that it's got to be 12.5 is the lowest it can go. So it's got to be bigger than that 12.5. But it can equal that 12.5 because it says it could get as low as, which means it could equal that 12.5. Okay. And that's what we do. And then we've got subtraction right here. The opposite or inverse of subtraction is addition. So I add, this is my bad. Negative 12.5. Sorry, guys. Sorry. We had 12.5 right there. You could use a calculator for that. Negative 12.5 plus 7.5 is going to get you negative 5. Okay. And what did I put in here? I started at negative 13 to include that, right? So negative 13, negative 12, negative 11, negative 10, negative 9, negative 8, negative 7, negative 6, negative 5. I might make these more bigger for you guys. More bigger. And so then we're at negative 5 right here, and it's going this way, so it's greater than. And since it's got the or equals to, it is a closed circle. Okay. All right. So solve the inequality and then graph it. And that's what we're doing right here. Okay. Solve the following inequality and then graph the solution that I just said that, right? So we've got this negative 1/2. The opposite being negative is positive. We're subtracting. So let's cancel out. We're left with x is less than negative 2/3 plus 1/2. Now, I know everybody's like, well, man, fractions and subtracting and adding. It's okay, guys. Don't worry. Okay. All right. The idea is you need to get the same number on the bottom. You need to get a common denominator. Okay. And the idea is that you will multiply this fraction on the top and the bottom by this denominator. Okay. And this should be. Let me just put this in here. Okay, because it's plus. Okay, so we multiply this, the top and the bottom, by that denominator, and then we multiply the top and the bottom here by this denominator, the number on the bottom. Okay, 2 times 2 is 4, 3 times 2 is 6. So this becomes negative 4/6 plus, and let's see, you've got x is less than all this, right? And then 3 times 1 is 3, 2 times 3 is 6. So now we have the same number on the bottom. Now what we do is we combine these. Negative 4/6 plus 3/6 is less than negative 1/6. Negative 4 minus 3, negative 4 plus 3, I'm sorry, is negative 1, and that 6 stays the same. And then we put this on the number line, okay? Just double check how I did this right here. I started at negative 1 over here, and then I kind of just went by 5/6, or by sixths, minus 4/6, which is the same thing as minus 2/3, and then minus 3/6, minus 2/6, minus 1/6, and that'd be 0. Okay. And this is less than, so it's going to go this way. Okay. And we're going to be at that 1/6. The arrow is going to go this way. And since it's saying it's less than negative 1/6, it does not include that negative 1/6. So we leave this open. So we leave that circle open. Okay. There you go, guys. Now you're equipped to go into the world, go to college, get a job. There you go.